Hi guys, we are starting our topic of equations. So we just got done simplifying expressions. Now we're going to actually be solving equations. So solving for x. So I think you've done this hopefully before in 7th and 8th grade, but we're going to do a review. And we're starting with basics. We're starting with one-step equations. One-step equations. Now, before you turn this video off and go, I already know how to do it, of course I'm going to put my own spin on it. I'm going to add a level of difficulty so that everything you learn in this video will help you for later lessons. So some of the stuff I talk about in this video is going to help you when we solve crazy equations such as this, okay? So the rules that we talk about today are going to help you solve more complicated equations. So it's important that you pay attention to this and take notes, okay? So first thing I want in our notebooks is what I kind of consider the golden rule of equations. So go ahead and write golden rule. That means that no matter what type of equation you solve, 1 step, 5 steps, whatever type of equation you solve, you always have to follow this rule, okay? So the rule is keep the equation balanced. Keep the equation balanced. All right, so I literally think of equations as like a teeter-totter. So remember when you were little and you went to the park and your brother got on one side and you got on the other? So a teeter-totter is, we can also consider a balance. There's a middle piece, it's called the fulcrum, that's the scientific name, and it keeps that in balance. So let's pretend that that teeter-totter was like this, it's level, nobody's sitting on it. If I sit on this side, what's going to happen to the teeter-totter? Does it go up or down if I sit on that side? It goes down. How would I get it back in balance? There's two ways. I could get off the teeter-totter, but maybe I don't want to. How could I get it back to being equal or balanced? Well, you'd have to put something over there of the exact same weight as me, right? To get it back to level. That's essentially an equation. So in the middle, the fulcrum, in an equation, it's called the equal sign. The equal sign is what's telling you that this side is equal to this side. It might look different, but it's equal, okay? So if I add 10 over here, it's gonna be off balance unless I add 10 over here. Okay, so your teachers have hopefully told you this phrase. I'm sure you can finish the sentence for me. Whatever you do to one side, you have to do to the other. Okay, so that's what you're gonna kind of write right here. Whatever you do to one side, you must do to the other. Okay, so I'm sure you've heard that before. And yes, there are two sides to an equation, the left side and the right side. So whatever I do to one side, I must do to the other. And that's what's cool about equations is you can manipulate them in so many ways. And it's legal to do as long as you do it to both sides. Okay. All right, now, so we have a golden rule. We always follow this rule. And then the whole point of an equation, we call it the objective or the mission or the goal, however you want to phrase that. I'm going to call it the objective, but it's like our goal, okay? So the objective, oh wow, objective, sorry about my spelling. Okay, and what I mean by objective is the whole point of this, the goal. what we want to do at the end here. Well, objective is to isolate the variable. That's the goal. Isolate the variable. Now, this word, isolate, think of what it means. If I said that girl's really isolating herself, or I feel isolated, it means by myself or on her own, right? So the same thing is true here. We want to get the variable, X, Y, W, whatever the variable is. We want to isolate it, get it by itself. We want to clear out all the other crap, so it's just the variable. Okay, that's what we're searching for. So how do we isolate it though? Well, you're going to use inverse operations. So let's write that down and I'll give you an example. Use inverse operations to get the variable by itself. Okay, so that's what isolate means, is get the variable by itself. Okay, so that's a fancy vocab word that you're going to hear me say a lot, and I'd love to hear you say. Okay, so another vocab word we should probably talk about is what inverse operations are. Inverse operations. Operations. Well, we've done order of operations: add, subtract, multiply, divide, right? Those are the 4 main operations. Inverse means like opposite. So think about, what's the opposite of addition? Subtraction, right? The opposite of addition is subtraction. Well, what's the opposite of subtraction? Addition. So it kind of goes both ways. Now, what I mean by this is they cancel each other out. So if you were to start at any number, pick a number in your head, or we can all just pick 50. If we start at any number such as 50, if you were to add 10, it would be 60. If you were to add 10, but then subtract 10, wouldn't you just go back to the starting point, which was 50, right? Adding 10 and subtracting 10 cancel each other out. They're inverse operations of each other. Now, what's the inverse operation of multiplication? Meaning, how do you undo multiplication? Well, you divide. It's a division. And if something is dividing by a number, I can undo it by multiplying by that number. Okay, so those are also inverse operations of each other. So for example, if you start at 50 again, that's our starting point. If I said multiply by 2, think about where you would be. You'd be at 100. Well, the opposite of multiplying by 2 is dividing by 2. So if you were to then divide by 2, you'd go back to your starting point. So they cancel each other out. They undo each other, okay? That's super important stuff, and that's always going to be true no matter how difficult of equations we're solving. So let's get right into this. We are starting easy, I realize that, but it's still good for you to be very clear on what you do and why. The why is the most important part. So let's just start with x minus 10 equals 3. Okay, I honestly hope you already know the answer to this, okay? Because x is some number, that's what we're trying to find, right? We're trying to isolate that x. Something minus 10 is 3. I bet you can figure that out in your head. I realize that. But once again, this type of equation is not something I immediately know. So we need to kind of follow these steps so that it becomes comfortable when we have to do something ugly like this, okay? So here's what I teach my kids to do every year. If you had me in 7th grade, you already know what's coming. Where this equal sign is, remember, that's the middle of your balance that separates the two sides. Go ahead and separate the two sides. That's really helpful when you get to like 2-step and multi-step equations, just to keep it all organized, but I would just start now, okay? Here's what I do. I go to the side with the variable on it, which is the left side, and I'm only focusing on that right now. I ask myself, is my variable isolated? No, it's hanging out with something. I don't want it to hang out with anything. I want to clear out everything. So it's just x, not x minus 10. So I ask myself, what's the opposite? What's the inverse of subtracting 10? How would I undo subtraction of 10? Well, I would add 10. So right underneath, guys, I'm going to show that I add 10. But I gotta keep the equation balanced. So whatever I do to one side, I have to do to the other. So if I add 10 on the left, I have to add 10 on the right. It's just the rules. You gotta keep it balanced. Okay, now let's kind of see what we're left with. Well, on the left-hand side, if I'm subtracting 10 and then adding 10, what's like negative 10 plus 10? It's 0. I don't even write the 0. What's the point of writing 0? It's nothing. So instead, I show that that cancels out, and I drop down what's left, which is x. I drop down my equal sign, and then I figure out what the right side equals. 3 plus 10 is 13. Okay? Now, how could we check to see if that's true? How could we check? And yes, I want you to do this off to the side, okay? At least on a couple. How could we check? Well, if x is equal to 13, why don't we just replace x with 13? This is called substitution. You're going to sub in the 13 for x and see if it's a true statement. If I plug in 13 right there, it would say 13 minus 10 equals 3. Let's go ahead and simplify the left side. 13 minus 10 is 3. The right side's already simplified, and you ask yourself, is this a balanced equation? Is 3 equal to 3? Yes, it is. And what that means, if this checks out, it means that we got the correct answer. Woohoo! Okay. I always ask my kids to check on their tests, because before you turn in your test, you would know if you got 100% just if you checked your answers. Okay. Number 2, x plus 8 equals 6. X plus 8 equals 6. So get in the habit, separating your sides. Separate your left side from your right side. Okay. I go to the side with my variable on it, which is the left right now. And I ask myself, is x by itself? No, it's hanging out with this 8. X is adding 8. I have to think about the inverse. What's the inverse of adding 8? What's the opposite of adding 8? Hopefully you said it. Subtracting 8. So right underneath, I'm going to show that I subtract 8. Whatever I do to one side, I have to do to the other. Positive 8 minus 8, what happens there? It cancels. That's the whole point of this. Those cancel, so we're left with x. We have isolated x, right? That's our objective. Now we just got to figure out what this side equals. 6 minus 8. 6 minus 8, is it 2 or negative 2? Negative 2. Okay. Now, if you're not good with negatives, you would definitely want to check. What you do is you plug in that answer that you got, you plug it in for x. Negative 2 plus 8 equals 6. I could take my calculator, I could type in negative 2 plus 8. Oh, that equals 6. Does 6 equal 6? Sure does. It's balanced. The equation is balanced. That means we got this correct. Okay, number 3. Number 3, negative 3y equals 18. Negative 3y equals 18. So I'm going to separate my sides. I'm going to go to the side with my variable on it. Our variable is y in this equation. Cool. Is y by itself? No, there's a stinking negative 3 attached to it. And if that negative 3 is attached to it, what operation is secretly happening between the negative 3 and the y? There's a secret multiplication, right? So your y, your variable, is multiplying by -3. What's the opposite of multiplying by -3? Well, the opposite of multiplying is dividing. So we would need to divide by -3. How we show division, now that you're in high school, now that you're in algebra, we don't use the division sign. No. That's kind of elementary. We use a fraction bar. Fractions mean division problems, right? So we need to divide by -3. Whatever I do to one side, I have to do to the other. So I got to divide this side by -3 as well. Now here's what happens. This might look weird to you. It's not, it's just a fraction. -3 divided by -3. Any number divided by itself is, and don't you dare say 0. It's not 0, people. Any number divided by itself is 1. Now, I go like this. It's kind of a slash, but it's also kind of a 1. Because if this is just 1 times y is just y. And that's what we wanted, right? So you can consider it canceling, but just know that it doesn't cancel to 0 like this does. This actually cancels to 1, but 1 times y is just y, okay? 18 divided by -3 is -6. Positive divided by negative is negative, okay? Now, maybe that wasn't comfortable to you, so we better check it. If I plug in -6 right here, I would have -3 times -6 equals 18. Notice how I use parentheses when I plug things in. I especially do that when it's multiplying, okay? -3 times -6, positive times negative times negative is positive. So that'd be 18 equals 18, which is a true statement. So we're good to go. Here's number 4. X over 5, look at that, make sure you wrote it down correctly. X over 5 equals -3. Now, before you freak out because you see a fraction, just don't freak out, okay? Let's approach it like we did the others. Separate your sides. Focus on the side with your variable on it. What is your variable doing? I always ask myself that. Up here, my variable was subtracting 10. So I decided to add 10, do the opposite. Here, the variable was adding 8. So what did we do? We subtracted 8. Right here, our variable was multiplying by -3. So we did the opposite. We divided by -3. Now, what is your variable doing? It's over 5. What does that fraction bar mean? Well, it means division. Your variable is dividing by 5. So what's the opposite of dividing by 5? Multiplying by 5. So you can show it with the multiplication dot. You can show it with parentheses, which is typically what I do. Okay, I do it both ways, but you need to show that you're multiplying by 5. Now here's why it works. Dividing and multiplying are opposites of each other. Remember, like say we start at 10. If I said take 10, I want you to divide by 5, you'd be at 2. But then if I said, okay, now multiply by 5, you'd be back at 10, which was your starting point. It cancels each other out. Dividing by 10 and then multiplying by 10 cancels out. I just put a slash through it. So what am I left with? I'm left with x, which is the whole point. And I just need to figure out what this is. -3 times 5 is -15. Okay, so you go to check that, right? You take your answer you got and you plug it in for x and you see if it actually makes sense. -15 over 5 equals -3. Well, what does this mean? It means division. -15 divided by +5 is -3. And then I would notice that, yes, that's a balanced equation. So I'm good to go. Okay. Okay. Number 5, -10 plus x equals 2. -10 plus x equals 2. This type of setup seems to throw kids off. They're used to seeing it like this, x minus 10. But did y'all know that x minus 10 is the same thing as negative 10 plus x? See how the negative 10 is still negative? See how the x is still positive, right? I don't rewrite it, but some of you might be tempted to rewrite it, which is fine, but I don't. It's just the same process. I go to the side with my variable on it. I can see that x is not by itself. It's not isolated. Well, what's with it? Negative 10 is hanging out with it, and it's being added, right? That throws kids off. They see this addition symbol and go, oh, I'm supposed to subtract 10. Well, let's think about that. If you were to minus 10 right here, because some kids do this, they see the addition and they go, oh, I'm supposed to minus. Does this cancel to 0? Remember up here, we canceled it to 0. We canceled it to 0. Does negative 10 minus 10 cancel to 0? No. So you wouldn't minus 10. If you see a negative 10, do the opposite, plus 10. Whatever I do to one side, I have to do to the other. Negative 10 plus 10 cancels to 0, which is what we wanted. A positive x is there, which is good. I always want positive x. And 2 plus 10 is 12. Okay? Now, let's just check it in our heads here. If I were to plug in our answer right there, I'd get my calculator and I would do negative 10 plus 12 is positive 2. 2 equals 2, so I'm good to go. Number 6, negative 12 equals 4w. Okay, on this one, separate my sides. I go to the side with my variable on it. Uh-oh, the variable's on the right-hand side. Do I freak out and stop? No. Who cares? It's on the right-hand side, whatever. Process is still the same. What is your variable doing? Well, it's connected to a 4. If they're squished together like that, what's happening there? Multiplication. Your w is multiplying by 4. So what are you gonna do? You're gonna divide by 4. Remember, we use a fraction bar. So I'm gonna divide that side by 4, which means I have to divide this side by 4. What's 4 divided by 4? Don't you dare say 0. 4 divided by 4 is 1. 1 times w is just w. Negative 12 divided by 4 is negative 3. Now, this is a true statement, negative 3 equals w, but in algebra, we always put our variable first. So you need to get in the habit of always writing your variable first. Well, if negative 3 equals w, then w equals negative 3. Okay? So if you wanted to check, you could plug that in right here. 4 times negative 3 is negative 12, which is what we had on this side. So that's correct. Okay? Now, we are going to kick things up a notch. So hopefully that was kind of some good review. Actually, these two problems, I would suggest, before we kick it up a notch, I would suggest pausing the video and trying them out, okay? So negative 3 equals 8 plus x. And then for number 8, you have negative x over 2 equals 5. Those are a little bit trickier, but they're fine. Pause the video, make sure you can do them, okay? And then play it if you need help or ready for you to check your answer. Okay, so number 7, I go to the side with my variable on it. My variable is not by itself. It's hanging out with a positive 8. How do I cancel out a positive 8? Well, I would need to subtract 8. Whatever I do to one side, I have to do to the other. 8 minus 8 cancels out. I'm left with x on that side. Drop down my equal sign. Negative 3 minus 8 is negative 11. So if negative 11 is equal to x, then that means that x equals negative 11. Final answer. Okay, number 8. I'm hoping that this negative didn't throw you off. Okay, so my variable is dividing by 2. So I'm hoping you're like, oh, I just have to multiply by 2. Well, kind of. If you multiply by 2, that'll cancel out the 2 on the denominator, which is good. But it doesn't cancel out this negative. We don't want negative x, we want positive x. So what you would actually need to do is times by a negative 2. Because what's a negative times a negative? Positive, and we want a positive x. So you actually need to multiply both sides by negative 2 on this one. That way I'm left with positive x, and then 5 times negative 2 is negative 10. Okay, now let's kick it up a notch. Here's number 9. Here is number 9. 2/3 x equals 8. Ooh, fractions. I know some of you see fractions and are just like, I can't, I'm done. Here's the thing. Fractions aren't my favorite, but I know how to get rid of them. It's true. You can get rid of fractions. This gross problem that I keep referring to, that's what we'll be doing in a few weeks, is canceling out fractions. It's such a beautiful thing. Okay, so that's what I want to talk about next, is what happens when your coefficient, remember coefficient is the number attached to x, what happens when your coefficient's a fraction? So let's call this fractional coefficients. Okay, so what's beautiful about mathematics, in my opinion, is that there's so many different ways that you could approach this problem. So I've made this little chart on different thinking strategies, different ways that people solve this type of problem. You do not need to write this down. You can, but you don't need to. I would actually rather you don't, and I'd actually just rather you listen, okay, for this part. So this green piece of paper, you don't need to copy down. So these are little thought bubbles. Some people, when they see fractional coefficients, they go here and they say, okay, well, 2/3 is multiplying by x. Now that's true. If 2/3 is smashed up with x, it means they're multiplying. So the thinking is, well, if it's multiplying by 2/3, wouldn't I just do the opposite and divide by 2/3? You could totally do that. You could divide both sides by 2/3. So I said, yeah, if you're comfortable dividing fractions. I know, because I taught 7th grade for 7 years. I know that you guys typically aren't comfortable with dividing fractions. You have to keep, change, flip, and all that stuff, okay? So then maybe we go to a different strategy. Here's another thing. Maybe multiply by 3 on both sides to cancel out the denominator. Because remember, like when we were dividing by 5, we times by 5 and it canceled out the denominator. So that could work. I said, yeah, but you'd be left with 2x and not x, because multiplying by 3 cancels out the denominator, but it doesn't cancel out that 2. So that it would be left with 2x, not x. Okay, so there would be more work to be done. So then another thought process is maybe cancel out the fraction somehow. And that's what I like to do. I like to cancel out the fraction. Now, if you would rather do it this way, fine. If you would rather do it this way, I get it, okay? Some kids do prefer this way better. I like to just do one thing to cancel out the fraction. So I'm gonna teach you my way, okay? So here's what you need to write down in your notes. Multiply the fractional coefficient by its reciprocal. cancel it to 1. Multiply the fractional coefficient by its reciprocal to cancel it to 1. It's a lot of language there. Pause it if you need to. Okay, so fractional coefficient is this dude, 2/3. It says we multiply the 2/3 by its reciprocal. So let's talk about that. Reciprocal means you flip it. Numerator becomes denominator, denominator becomes numerator. So if I have 2/3, what's the reciprocal of 2/3? Literally just flip it. 3/2. Okay. So if I multiply any fraction by its reciprocal, it's going to cancel to 1. Let me prove it to you. If you were to go ahead and multiply, pretend this is multiplication here. If you were to multiply 2 times 3, 6, 3 times 2, 6, what's 6 divided by 6? 1. It cancels to 1, okay? Another example, if your fractional coefficient was -1/5, well, the reciprocal of -1/5 is -5/1. I literally just flipped the numerator and denominator, okay? If I were to times that, well, first of all, a negative times a negative is positive, right? Multiply the tops. 1 times 5 is 5. 5 times 1 is 5. 5 divided by 5 is 1. If you multiply any fraction by its reciprocal, it'll cancel to 1, okay? So let's try it out. I'm gonna drop this down just so you can like see the work a little bit better. Okay. So if I times this side by 3/2, right? Because that's the reciprocal of 2/3. Well, whatever I do to one side, I have to do to the other, times by 3/2. Okay, what happens here? This cancels out. I proved it to you right here. It cancels out because if you were to multiply it up, it'd be 6/6. 6 divided by 6 is just 1, and 1 times x is just x. Boom, we did one thing to cancel out the fractional coefficient. So the work you have to do is take your calculator and figure out what 8 times 3/2 is. Or you could go old school and go, okay, I put that over 1, right? It's a whole number, so put it over 1. I multiply the tops. 8 times 3 is 24. 1 times 2 is 2. What's 24 divided by 2? 12. Final answer. Okay. So that's how you get rid of fractional coefficients. Let's try it on a few more problems. Okay. Number 10, 3/4 x equals -6. 3/4 x equals -6. So I look to the side with my variable on it and I go, uh-oh, fractional coefficient. How do I cancel it out? I multiply it by the reciprocal. So what's the reciprocal of 3/4? 4/3. So over here, I'm just going to times by 4/3, which means I have to times the right side by 4/3. What's cool is this cancels out to 1. 1x is just x, so I've isolated my variable. Yay. Just got to do some math over here. I'm going to put this -6 over 1, multiply straight across. -6 times 4 is -24. 1 times 3 is 3. -24 divided by 3 is -8. Okay. This one, I want you to try it. So pause the video, see if you can do it without my explanation. -1/3 x equals 5. Okay, I see a fractional coefficient, so I'm going to use the reciprocal to help me out. The reciprocal of -1/3 is -3/1. So if I multiply by -3/1 on both sides, that'll cancel out this garbage and leave me with just x. Then I have to do a little bit of multiplication over here. 5 times negative 3 is negative 15. 1 times 1 is 1. Negative 15 over 1 is just negative 15. Final answer. Okay, so here are your practice problems that are going to turn into entry task questions. So these are the problems I want you to do before you come to class. You have 4 one-step equations to do. That's it. Okay. Here we go. Number 12. X minus 12 equals negative 2. Number 13. Negative 5x equals 30. Number 14. X over 4 equals 5. And last one, it's a fractional coefficient. 2/5 x equals negative 4. Those are your 4 problems I want you to have done before you come to class. Thank you so much. Yay, math. You guys have a good day. See you in class.